Unit 7, Day 7, we are going to talk about comparing linear, quadratic, and exponential functions. Our essential question today is how can you compare linear, quadratic, and exponential functions? So I just want to refresh your memories. The names of our functions are in this left-hand column. So when we're talking about a linear function, we are talking about an equation that is y equals mx plus b. When we are talking about the equation y equals mx plus b, we are looking at something that contains no exponents. When we graph a linear function, it is going to have a y-intercept and it is going to be a straight line. Looking at the next function, we are talking about a quadratic function. A quadratic function has the equation y equals ax squared plus bx plus c, and it forms a U shape. So please make note that a quadratic function must have an x squared term. Last function that we're covering currently is exponential functions. An exponential function has the equation y is equal to a times b raised to the x power, and it gives us a quick curve on our graph. So please take note that the exponent is always your variable. So right here, our exponent is what we are going to be plugging into. So example 1 says, tell whether each equation represents a linear, a quadratic, or an exponential function. So when we look at equation A, you should notice that this equation has an x squared term. If we have an x squared term, it must be a quadratic equation. Looking at example B, we have 3x minus 6 divided by 2. There are no variables as exponents, and there are no x terms, so this is an example of a linear function. So there are no exponents. In A, we said there is an x squared, so it's quadratic. Looking at example C, we have h of t is equal to 4 times 0.932 raised to the t power. So we can see that we have a variable as our exponent, and when we have a variable as our exponent, we are talking about an exponential function. Example number 2 says plot the points. Tell whether the points appear to represent a linear, a quadratic, or an exponential function. So remember when we plot our ordered pairs, the first thing in your ordered pair is always your x followed by your y. Please remember your vertical axis is your y-axis, your horizontal axis is your x-axis. So in example A, the first point is negative 1, 5. So negative 1, 5, 2, negative 1, 0, negative 1, 3, 5, 1, negative 3. So what function does this represent? A U-shaped is absolutely a quadratic. Let's plot the next points. So if we have negative 1, 2, negative 2, 8, negative 3, 32, whoops, that's off our graph, 0, 1/2, 1, 1/8. If we connect these green dots, we see that our graph is approaching 0 but not touching it. It's a quick curve, so we have an exponential function. And looking at our last ordered pairs, negative 3, 5, 0, negative 1, 2, negative 5, negative 4, 7, 1, negative 3. We can see that if we connect these lines, it gives us a nice straight line with an even slope. So we say it is a linear function. So please remember this. If we have a linear function, we are adding. So we are adding or subtracting to go from one term to the next. So linear is add slash subtract. Exponential functions are when you multiply. Technically, you could say you divide also, but that's really multiplying by a fraction. And a quadratic function, so we want to take note that a quadratic function, if our x's are increasing by 1, then when we do our first difference, so we find how negative 1 changes to negative 2, we have negative 1, then we have plus 1, then negative 1 to 2 is plus 3, then we have plus 5. So you can see your first difference is different, but you want to try it one more time. So then you want to find the difference, the second difference, which is how do you go from negative 1 to positive 1? You add 2. 1 to 3, you add 2. 3 to 5, you add 2. So if the second difference matches and is adding, it is a quadratic function. So let's tell now from a table whether these represent linear, quadratic, or exponential. So when we increase negative 1 to 0, plus 1, 0 to 1, plus 1, 1 to 2, plus 1, we're increasing by a constant on top. To go from 1 to 3, I multiply by 3. 3 to 9 multiplied by 3, 9 to 27 multiplied by 3. So because I'm multiplying, this is an exponential function. When we look at the next chart, 2 to 4, we're increasing by 2, increasing by 2, increasing by 2. So we're increasing at a steady rate. To go from 12 to 0, I subtracted 12. 0 to negative 4, I subtracted 4. Negative 4 to 0, I added 4. And 0 to 12, I added 12. So my first difference didn't match, but I want to try it again. How do I go from negative 12 to negative 4? Add 8. Negative 4 to 4, add 8. 4 to 12, I add 8. Our second difference right here is all doing the same thing. So I have a quadratic function. So the last thing we want to look at are some situations. And now we want to determine from the situation, is it linear, quadratic, or exponential? Example 4a says a single elimination tournament bracket starts with 64 teams. So if you think of March Madness and you think of a bracket with all 64 of these teams, once a team's eliminated, you get to a smaller bracket, and then these teams would play each other and you would have the winner eventually. So what kind of function do you think this represents if you go from a lot of teams to one team very quickly? An exponential function is correct. Example 4b says every month the fitness club gains 10 more members. So if we are gaining 10 members at a constant rate every month, we are adding 10, we would say that is an example of a linear function. If we are thinking about the height of a basketball after it is shot, so we are shooting at our basketball goal, and if we shoot the basketball and we think of the height after the ball is shot, what kind of function does that form? Absolutely, a quadratic function. You now complete your worksheet for day 7.